Today we're going to be focusing on what factors affect the energy on a roller coaster. So in a roller coaster, we have two types of energy. We've got kinetic energy and potential energy. The word kinetic we've heard before, and it means movement. So whenever the coaster is moving, it has kinetic energy. Potential energy is also just what it sounds like. The coaster has potential to have a lot of energy when it's at the top of a roller coaster. We'll start with kinetic energy. Kinetic energy is the energy of motion, and it depends on the object's mass and the velocity. So a bigger car has more kinetic energy than a smaller car. Same with when you're kicking a soccer ball. A soccer ball has more kinetic energy when the velocity is greater. So when it's kicked with a higher force, it has a higher speed and therefore greater kinetic energy. Just a reminder, you can set up the notes how you want. Here is an example of how to set up your notes, but you're choosing what is important to write down. So kinetic energy has a formula that goes with it, and you can actually calculate the kinetic energy of an object. Kinetic energy equals half times the mass of the object times the velocity of the object squared. So Ke equals half mv squared. So here is an example. The bowling ball is whizzing down the bowling lane at 4 meters per second. If the mass of the bowling ball is 7 kilograms, what is its kinetic energy? Just like how we've set up problems before, we're going to set them up the same way. We're going to start by writing down what we know. Here we know the mass of the bowling ball is 7 kilograms and the velocity is 4 meters per second. Then we'll write the formula. Kinetic energy equals half mv squared. We'll plug in those numbers and we'll get a final answer. Energy is measured in joules, so your units for energy will always be a J for joules. So with this calculation, we calculated that the kinetic energy of the bowling ball is 56 joules. So here I wrote down the problem in my notes and how we answered it. Potential energy is energy that is stored in a person or in an object. So it depends on its position or its shape. So for example, with the bow and arrow, as she pulls back her bow further back, there's more potential energy being stored in that band. Here with the kid jumping off the diving board, when he's at a higher height, he has more potential energy. So at the very top of the diving board has a higher potential energy than the lower diving board. Potential energy turns into kinetic energy. Potential energy is right before the object moves. So it's got that potential to have a lot of energy, and then it turns into kinetic energy once it's moving. So just like with kinetic energy, potential energy has a formula as well. Potential energy equals the mass of the object times the gravity times the height. Here's an example. A 90-kilogram man climbs hand over hand up a rope to a height of 9.47 meters. How much potential energy does he have at the top? So same thing, we're going to write down what we know. We know the mass of the man is 90 kilograms, the height is 9.47 meters, and the gravity is always the same. You're going to use that same number to plug in for gravity every time. Gravity is 9.8 meters per second squared. We've learned that all objects on Earth fall at the same rate. They all fall at 9.8 meters per second squared. Then we'll plug in our formula. PE equals M times G times H. Plug in our numbers, and we'll get a final answer. Again, potential energy is measured in joules, and we'll use J as the abbreviation. So go ahead and take the time to write or type your notes. So let's look at this example. In this roller coaster, it's gaining potential energy as it goes to the top. So at the very top of the hill, it has the most amount of potential energy. At that very split second before it goes down the hill, it does not have any kinetic energy because it's not moving. At the bottom of the hill is where the greatest amount of kinetic energy. All of that potential energy has transformed to kinetic energy. That's where it's going the fastest. And then you can see how potential energy is gained and transferred to kinetic energy. One thing to keep in mind about this example is that it does not talk about loss of energy due to friction. In the real world, there is friction that occurs between the wheels and the ramp of the roller coaster, which causes a thermal energy and friction, which is energy lost. But with our examples, we're just going to be looking at the kinetic and potential energy as well as the total energy. And that is all for our notes.